Hello, welcome to ANS Solver. This is the ninth question of the paper. So here the variables x and t satisfy this differential equation where x equals to 10 and t equals to 0. We need to use partial fraction and solve this differential equation obtaining an expression for x in terms of t. So what we basically need to do here is first get it in the variable separable form where we write the x's together, which is 5 over 20 minus x into 40 minus x dx, which is equal to 1 into dt. Obviously, because it's just dt, I know, but just write it 1 into dt. Okay, so now I can simply integrate both sides. So what I can do is I can split this into parts. Okay, two parts here. So the first part, the integration of 1. The integration of 1 will be t, correct? Because there are no limits, it's indefinite integration. I'll add a c with it. Agreed? So now what I'll simply do is I need to solve this. But solving this directly is not easy. So what I'll do is I'll convert 5 over 20 minus x into 40 minus x into partial fractions. Okay, partial fractions where I can write this as a over 20 minus x plus b over 40 minus x. Correct? This is how I can write. So now I can take the LCM and write this as a into 40 minus x, okay, plus b into 20 minus x. And the denominators from both sides cancel off. Correct? This is how we solve. Basic concept. Now let's say if I want to find a, I know this full part needs to be 0. So I can simply say for finding a, my 20 minus x should be equal to 0, which gives my x as 20. So I can simply substitute x as 20 in the equation. So now 40 minus 20 gives me 20, so I get my a as 1 over 4. Okay, so now what I can simply do is I need to find b. So finding b, I know this full part needs to be 0. So for that, what I can simply do is, I know 40 minus x needs to be 0. Okay, so I can simply say x equals to 40. So what I can say is 5 equals to 20 minus 40 here. 20 minus 40 is simply minus 20, which gives me my b as minus 1 over 4. So now what I can do is I can write this in the partial fraction form where I can write this as 1 over 4 into 20 minus x, okay, minus 1 over 4 into 40 minus x, okay, 40 minus x. Got it? Now I need to integrate something like this, correct? Because now I've just written this in the partial fraction form. Now the main process of integration is left. So what I can do is I can take 1 over 4 common here and I can write this as integration of 1 over 20 minus x minus 1 over 40 minus x. So I can write this as 1 over 4 multiplied by 1 over 20 minus x. First I'll write this as ln 20 minus x with the numerator, which is 1, over the coefficient of x, which is minus 1, minus, I can now write this as ln 40 minus x over 1 over minus 1. Correct? This is what I can write. So this can basically be written as 1 over 4, okay, with minus ln 20 minus x, okay, plus ln 40 minus x. Sorry, this is 40 minus x. Now what I can do is I can rearrange it as 1 over 4 with ln 40 minus x minus ln 20 minus x. Correct? So now the equation or the log property which I can use here is simply log of a minus log of b can be written as log a over b. So using this log property, I can simply write this as 1 over 4 ln 40 minus x over 20 minus x. Correct? So now writing everything together, I can write this as 1 over 4 ln 40 minus x over 20 minus x, which is equal to the right hand side, which is t plus c. So I can write this as t plus c. Correct? Now what I can do is I can write this as ln 40 minus x over 20 minus x, okay, equals to 4t plus a constant. 4 into a constant will give us a constant. So I can just write this as c. Now another log property, a major log property which I can use is that log of b with the base a equals to c can be written as b equals to a raised to c. So now what I can do is I can use this log property and write this as 40 minus x over 20 minus x equals to the base of ln is e. So I can write this as e raised to 4t, okay, plus c, which can be written as 40 minus x over 20 minus x equals to e raised to 4t into e raised to c using normal indices. So now I know that e raised to c is also constant. So I can say this constant here can be written as a. So I can write this basically as 40 minus x over 20 minus x equals to a into e raised to 4t. So now what I can simply do is, you know, your x is 10 here and your t is 0 here. So I can simply say x equals to 10 and t equals to 0. So now 40 minus 10 will give me 30 over 20 minus 10 will give me 10 equals to a. Here I know 4 into 0 will give me 0 and e raised to 0 is 1. So I'll get my a as 30 over 10, okay, which will give my a basically as 3. So now writing the equation again, I can write this as 40 minus x over 20 minus x, okay, equals to 3 e raised to 4t. Agreed? But now the last step is left, which is writing x in terms of t. So I need to write it as x equals to something. So I can now write this as 40 minus x equals to 3 e raised to 4t into 20 minus x. So now this can basically be written as 40 minus x equals to 3 into 20, which is 60. 60 into e raised to 4t, okay, correct, minus 3 e raised to 4t x, correct. So now what I can do is I can keep the x's to one side and the other constants to other side. So I can write this basically as 3 e raised to 4t into x minus x equals to 60 e raised to 4t minus 40. Correct? Now here I can take x common to simply get 3 e raised to 4t minus 1, which is equal to 60 e raised to 4t minus, sorry, the minus is down here, minus 40. Correct? So where I can write this as x equals to 60 e raised to 4t minus 40 over 3 e raised to 4t minus 1. So I can simply say this is x, correct, in terms of t. Okay? Now, the b part. State what happens to the value of x when t becomes large. So I know my x is basically equal to 60 e raised to 40, 60 e raised to 40, correct, minus 40, correct, over 3 e raised to 40 minus 1, correct. Now let's say if t becomes large, like they are stating, t becomes something in millions, trillions, whatever. So obviously my 40 and my minus 1 will become insignificant, like there won't be any significance of it. Okay, so I can simply say now x is equal to 60 e raised to 40 over 3 e raised to 40, correct, because 40 and minus 1 are insignificant. So I can remove, now cut both of this to get x equals to 60 over 3, which gives me my x basically as 20. So I can simply say as t becomes large, okay, 40 and minus 1 becomes insignificant and x tends to 20. Okay, yeah.